Hello! We're going to be talking about the Pythagorean theorem today. Now, this is one thing that, for some reason, a lot of people tend to remember after they leave high school. They say, oh man, I didn't learn any math. The only thing I know is something about a squared plus b squared and c squared. And that's fine. Now, because I'm super nerdy, I actually use this kind of stuff. Like one time a few summers ago, as I was swimming laps in the pool, and I was swimming back and forth, I was like, oh, hey, what would happen? I get tired of flipping at the end of the pool. So what would happen if instead of swimming, back and forth like this, what about if I swam more like this? And so I got out and measured the pool and did some quick calculations because I want to know how long it was. Now that's just because I'm super nerdy. I don't expect too many other people to do that. But the Pythagorean theorem, like I said, is something that a lot of people do learn in high school and they tend to remember it. And it's just that one leg squared plus the other leg squared is equal to the hypotenuse squared, or in other words, a squared plus b squared equals c squared. Now, the two legs do not matter. Doesn't matter which leg is which. The only thing that really matters is that the longest side is called the hypotenuse. That one always has to be c. It doesn't matter if you let this one be a and this one be b, or if this one's a and that one's b. Doesn't matter at all. Now, the other thing that you can do with this equation, if you want to, would be to say if we solve this for c by square rooting both of these, then we could say something like this. We could say c is equal to the square root of a squared plus b squared. So if you have to solve for the hypotenuse, then that's ultimately what we're going to do. Okay, so there's all different ways of showing this. You can see here's a triangle that has 3 on one side, 4 on another side, and 5 on another. Wow, that was an awful triangle. Let's fix this up a little bit, and let's see if I can't draw some better lines here. All right, let's see here. There's one side. There's one side. Hey, look at that. I can draw straight lines, sort of. Okay, so there's our triangle, and it's a 3, 4, 5 triangle. And you can see that if you do actually square this side, meaning you take it times itself, so 3 times 3 makes a square of 9 units. And if you take 4 times 4, that gets you a square of 16 units. And if you do 5 times 5, that gets you 25. So this is actually what you call a Pythagorean triple because these come out to be nice. But this is true for any right triangle. Okay. All right, so let's look at a few examples here. Here's one that we've got maybe where we're trying to find the hypotenuse. So we would actually take the leg and the other leg, and we would square those, and we would say 3 squared plus 4 squared. We go through and say 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. Notice that I do that inside the radical first. Don't take the square root of 9 and the square root of 16. You'll be right back where you started. Okay, but that does end up getting us 5 then for the longest side. And if you have to find one of the other sides, like maybe here you have to find one of the legs, then all you would do is you would actually subtract the squares. Right? That's because you can still use this a squared plus b squared equals c squared thing. You just put in what you know and solve for what you don't. If we don't know the other leg, it might look something like this. Then I would go through and subtract 4 squared from both sides. So a squared equals 5 squared minus 4 squared. Then we would square root everything. So I get a equals the square root of 5 squared, 25, and 4 squared, 16. That's the square root of 9, which is just regular 3. So this side length is a regular 3. Now I know some of you are like, oh, of course it is. Look, it's the same triangle. I know. I'm just showing you what you would do to solve for that other side. If you have the hypotenuse, you're going to end up subtracting the squares. If you have the legs, you need the hypotenuse, then you add the squares. Okay? All right, let's move on to one maybe that has some slightly different numbers, and then one that's pretty similar to what we just did. So here I've got a 5 and a 12 and I don't know. Now, this side here is the hypotenuse. It's the hypotenuse because it's opposite the 90-degree angle. It's the longest side. That means I'm going to be using the a squared plus b squared equals c squared, and I'm going to be putting those in for a and b. So this will be 5 squared plus 12 squared equals the question mark, which I'm just going to call c squared. And now in order to get that c alone, right, we square root both sides. So ultimately what I would say is c is equal to the square root of, and now I'll just do these. 5 that squared is 25. 12 squared is 144. And then we'll say add those together, that makes 169. And then finally, the square root of 169. If you need to do that on your calculator, you can, but that is a nice one. It's actually just 13. You could check this out by saying 13 times 13, right? And you get 169. So that's how we know we did it right. So this side length here comes out to be 13 feet. Okay? Okay. Let's go ahead and take a look at the next one here. Now this is one, again, we've already done this. We did this one on the last page, right? If we do a squared plus b squared equals c squared, you can see that ultimately what's going to happen here is we know the hypotenuse. So this is one where we're going to be subtracting them because we've got to find that one. If you want to plug these in, you can. Just looks like that. And so we don't know this one. We're going to subtract this over. So I could say this, a squared equals 25 minus 16. I just squared those. C squared equals 9, and then C will equal 3 because we're going to square root them. This will be 3 meters. Don't forget your label. Okay. All right, let's look at just a few more examples here. Here I've got one that is it's a hypotenuse. So I could think of it like this. I can say C is equal to a squared plus b squared square rooted. You know, that's just solved for C. And then I'll have 8 squared plus 15 squared. Of course, you can use just that basic a squared plus b squared equals c squared as just showing you that you can kind of modify it a little bit to go directly to the c. Right? If you want to, plug them in just like normal and then square root it at the end. It's totally fine. So we get to here. And now when I add these together, I'm going to get, let's see, 4, that's a 9, 8, 2. Now, 289, that's actually a nice square root. 17 squared is 289. But I don't really expect a lot of people to know that right off the top of their head unless you're a math person. So, you know, a calculator's nice, or you can start guessing. You know, just plug in some numbers in and see how close you could get. Okay, here's the last one here. These, you would do a squared plus b squared equals c squared. Notice this is the hypotenuse, so this will actually have to be your c. The other sides don't matter because they're a and b. But like what we talked about before, if you have this equation and you have to solve for one of the sides, you could actually subtract the b squared and then square root both sides. And so it's kind of like just plugging it into just one place. If you have to solve for a leg, you can just plug them in right here. This will be 25 squared minus 24 squared and then square rooted. Or 625 minus 576 square rooted. And when you subtract those, we end up getting, let's see, 24 and 20 makes 49. Okay, square root of 49 is just 7. So 7 centimeters. Okay, a squared plus b squared equals c squared. Let's try sketching a right triangle with one leg that's 8, the other leg that's 12, and then find the hypotenuse. So it doesn't matter how you draw it, just make one leg a little bit longer than the other. We're just approximating. I missed it. All right, and then we'll say 8 centimeters, and we'll do 12 centimeters. And in order to find the last one, we do a squared plus b squared equals c squared. Or in other words, c is equal to the square root of 8 squared plus 12 squared. Now, this one isn't going to come out as nice as the others. This comes out to be square root 208. And if you try to figure out what that might be, it's not very nice. So we can do a couple things. I can just leave it like this, square root 208 centimeters. Okay. The thing is, like, if I started trying to like guess around, I would say, well, I know that 14 squared is 196 and 15 squared is 225. So this is somewhere between 14 and 15. And that should kind of make sense just from our triangle. If we have a side length 8 and one side's 12, it would make sense that the other one is just a little bit bigger. Like the hypotenuse has to be the biggest side, so it's got to be bigger than 12. Okay. The other thing that you could do is you could grab the calculator and you could punch in square root of 208, and you would get about 14.42 centimeters. Okay, that's another thing you could do. Now, where you would probably definitely do that, probably definitely, that's kind of contradictory, but whenever you're working with real world problems, like actual measurements, like that makes sense to use decimals. Of course, it makes sense when you're working in the real world to have decimals. Like to say I need a piece of rope that's radical 2 feet long, that's pretty difficult. So you would probably want to round it and say I need a piece of rope that's about 1.4 inches long or 1.4 meters or whatever it is. So that definitely makes sense to use decimals when you're talking about real world examples. Now, when I look at this, it says I have a 25-foot ladder. So here's the length of the ladder. It's 25 feet. It's placed against a wall and it's 21 feet above ground. Okay, so we have a 25-foot ladder and it's leaned up against the wall and the top of the ladder is 21 feet above ground. How far is the base of the ladder from the wall? These leaning ladder problems are really popular in math. They're kind of fun. And then when you get to calculus, you'll start talking about what if somebody was to pull the end of the ladder away and how fast is the ladder going to fall, and use calculus to figure it out. It's pretty interesting. All right. So we've got 25 feet and 21 feet. And then this is what we don't know. If I'm trying to figure out what this side is, that's just one of our legs, then I can use that subtraction one, right? I have the longest one, so I might say something like this, like it's equal to 25 squared minus 21 squared. Okay, and so I can say 625 minus 441, all inside a square root. When you subtract those out, you get 184. And then this one here, it says to the nearest thousandth. So square root 184, let's clear this out. Square root of 184 is 13.5646. 13.5646. I said it like 3 times and I still can't get it right. 646. There we go. It says to the nearest thousandth. That means this one. So I've got to look at this one here and decide. That one's larger, so it means I'm going to round up. If I round this to the nearest thousandth, it will be 13.565 feet. Okay, because we had to round that up. All right, next, let's find the distance between the centers of the holes in this metal plate. So there's some metal plate, and here's the holes on it, and we want to know how far apart this is. Okay, so we know that this is 3 centimeters from the center to there. We know that from the center to here is 8 centimeters, and ultimately what they want us to do is to find how far it is from there to there. We want to know the length of that black line. So what we've got here is just another right triangle. Right? Here's 3 by 8 by I don't know. A squared plus B squared equals C squared, or since we're trying to find the longest side, we're going to add the squares. So it'll look like this. Now I've got 9 plus 64 makes 73. And then again, it does say to the nearest thousandth, so we'll push that in the calculator and we do the square root of 73, and I get 8.5440. And if I'm trying to go to here, then that's a no-brainer. We just cut it off and be done. If your calculator isn't giving you an answer, maybe you punch in square root of 73 and it just says square root 73, then you might want to go online and look to see how you can get that decimal. Like I'll tell you on my calculator, I actually have a little button right here that says FD, right? That says change the form to a decimal. So like sometimes when I do this in my own calculator, I have a Casio Prism, it just spits out the square root of 184, and I have to hit that FD button to turn it into a decimal. So be on the lookout for that. If you don't have a button like that, maybe go on to a search engine and just try to search that, how to change irrational numbers on your whatever model calculator you have. All right, we've got 2 more to look at here. We have if you're traveling 18 miles east and then 12 miles north, how far from your starting point are you? So you started here and you went 18 miles east, then you went 12 miles north, then how far are you from your starting point? Like what's this distance here? This is what we're trying to find. So because we're trying to find the longest side, then we will be adding them. We'll say C is equal to 18 squared plus 12 squared. 18 squared is 324, I hope. And 12 squared is 144. If I'm wrong, I'm sure I'll. If we add those together, that will get us 468. And then we'll need to go ahead and check that in the calculator, and we'll do the square root of 468. So square root of 468. I get 21.633, and notice this time it says to the nearest tenth. So 21.633, but it says tenth. So we've got to pay attention to that. That means 1 decimal place. So I'll look behind it, and I see that this 3 is smaller than 5. So ultimately what's going to happen is that's just going to get chopped off. That's what it means when we're rounding and it's smaller than 5. So now I have 21.6 miles. That's how far we traveled. Okay. The last one here, I've just got this nice little triangle given, and we want to find the hypotenuse, the perimeter, and the area. This is just kind of summarizing some things that we've already done, finding area of simple shapes like that. So hypotenuse, that's going to be the square root of, since we're finding the hypotenuse, we're going to sum the squares. 5 squared plus 12 squared. 5 squared is 25, 12 squared is 144. I know some of these seem like repetitive, but that's because these Pythagorean triples are really nice, and you don't have to worry about decimals as much whenever you're dealing with these nice Pythagorean triples is what they're called. It means the square roots come out to be nice numbers, nice integer values. So square root of 169 is 13. So the hypotenuse is 13 centimeters. Now that we know that, we could actually find the perimeter. We couldn't find the perimeter before. Now we can. So we've got 5 plus 12 plus 13 makes 30. 30 centimeters all the way around this triangle. Lastly, let's find the area. Area, of course, is 1/2 base times height on a triangle. So 1/2 of 12 times 5. Okay. Not this 13. Well, that's going to be half of 60, which comes out to be 30. And so our area is 30 square centimeters. I feel like I need to point out, even though I probably shouldn't, that the perimeter and the area are not always the same. That's just happens to be the case this time. They come out to both be 30. But in truth, these are very different 30s. This is 30 centimeters. It's a linear measurement. You could measure this with a ruler. Area is square centimeters, and that's a big difference, right? You can't just take a ruler and find 30 square centimeters. Like a ruler measures linear. You have to go in another dimension. So please pay close attention to your labels. Perimeter is just centimeters. Area is centimeters squared. All right, well, I hope that this has been useful in finding the hypotenuse, and hopefully you will be able to do well. There's a lot of great jokes out there involving the hypotenuse and Pythagorean theorem. I just didn't throw them on here. You can also find some really great history on the Pythagorean theorem. There's a lot of really great YouTubers out there that have some fantastic content if you want to learn a little bit of history. So you can check those out as well, and have a good day.